On today's episode, China reveals a bold new plan to explore the solar system, while NASA finds something potentially game-changing on the planet Mars. ESA updates their own plans to land on Mars, while Europe's newest rocket has an unexpected and explosive return to launch site. China has a new plan, and it involves the majority of our solar system, from Venus all the way out to Neptune. Most of this sounds fairly practical, but some of this stuff is downright insane. Meanwhile, NASA's Curiosity rover has just discovered the largest organic molecules ever detected on the red planet, complex carbon chains that could be the remnants of ancient life. And in Europe, a highly anticipated rocket launch went catastrophically wrong in a way that reminds us just how difficult spaceflight really is. Let's break it all down. The Chinese recently created a new entity called the Deep Space Exploration Laboratory, the purpose of which is to strengthen the country's approach to exploration of the solar system. The laboratory is a partnership between China's National Space Agency and the University of Science and Technology of China. It's not just a research center, it's a coordinating body designed to plan, fund, and execute some of the most ambitious robotic missions ever conceived. And we know that China has been very active with its exploration of the Moon, including the first rover and sample return from the lunar far side with Chang'e 4 and Chang'e 5. The Chinese were also the second nation, after the USA, to successfully operate a rover on Mars with their Zhurong rover, so they're coming to the table with some pretty solid credentials. They've proven they can land complex spacecraft on other worlds and bring samples back to Earth. This isn't just talk. They have a track record of delivering on ambitious promises. Here's what China has planned for the next decade. And it's aggressive. 2028, Tianwen-3 mission to Mars. This mission will collect samples of Martian soil and rocks for immediate return to Earth. This is one that we already knew about, but it's always good to see that the plan is still on track. If successful, this will be the first ever Mars sample return mission, unless Elon Musk can somehow swoop in with a Starship and beat them to it. NASA's own Mars sample return program, which has been in development for over a decade, is currently being rescoped due to budget overruns and is unlikely to launch before the early 2030s at the earliest. China could legitimately beat NASA to this milestone. 2029, Tianwen-4. This mission is headed to Jupiter to explore the gas giant and its moon Callisto. This is also one that we've heard about previously, and it's an interesting mission profile because Tianwen-4 will join NASA's Europa Clipper mission, which is studying the Jovian moon Europa, and the European JUICE probe, which will primarily investigate Ganymede. So that gives us up-close studies for 3 of the 4 large Jovian moons, Europa, Ganymede, and Callisto, leaving Io, the volcanically active moon, as the odd one out. It's remarkable that we'll have 3 separate spacecraft from 3 different space agencies all studying the Jupiter system simultaneously. 2030. This one happens on Earth. China calls for the development of a large ground-based habitat to simulate long-duration human spaceflight. Think of it as essentially a Mars and Moon-based simulator, a controlled environment where they can test life support systems, food production, psychological effects of isolation, and all the other challenges of living on another world for months or years at a time. This is a critical step if they're serious about putting humans on Mars, which they've stated as a long-term goal for the 2040s or 2050s. Now things get really interesting, and ambitious to the point of sounding almost impossible. 2033. A mission to Venus that will return samples of the atmosphere to Earth. This one is pretty crazy. Venus is one of the most hostile environments in the solar system. Surface temperatures reach 475 degrees Celsius, hot enough to melt lead. Atmospheric pressure at the surface is 92 times that of Earth's, equivalent to being 900 meters underwater. And the clouds are made of sulfuric acid. But I guess it depends on how deep into the atmosphere they're planning to go. You could dip down with something like a glide vehicle, or float in on a balloon, inhale a bunch of gas, and then fire up a propulsion system to return to orbit before the heat and pressure destroy your spacecraft. This is the first I've heard of a legitimate Venus sample return mission. The Soviet Union's Venera probes landed on the surface in the 1970s and 1980s, but they didn't bring anything back. If China pulls this off, it would be unprecedented. 2038. Establishment of an autonomous Mars research station to study in situ resource utilization. Pretty much a robotic Mars base. In theory, this would be very similar to what China is planning to do with their International Lunar Research Station, a robotic outpost with a similar goal: to lay the foundations for long-term human exploration by figuring out how to use local resources to produce water, oxygen, rocket fuel, and building materials. 2039. A mission to Neptune's largest moon, Triton. This would include a subsurface explorer for the moon's ocean. Just like Europa and Enceladus, it's believed that Triton has an icy shell with a saltwater ocean underneath. But we're not sure how thick that shell is. Some estimates put it at tens of kilometers thick. Any assumption that we could either drill or melt our way through it and drop a submarine down there would be ambitious at best, especially considering the mass limitations when sending something that deep into the outer solar system. Unless we can unlock a much more efficient propulsion system by 2039, potentially something nuclear-powered, and that's not too far of a stretch. NASA's been developing nuclear-electric propulsion systems for deep space missions, and China has hinted at similar programs. So this is definitely a roadmap that we'll be watching with great interest over the years to come. And timing-wise, China's announcement comes during a period of great uncertainty at NASA. They're staring down some potentially devastating budget cuts. They still have no confirmed administrator under the new administration. The Artemis program, the plan to return humans to the moon, is not looking so good with delays and cost overruns plaguing every element. And their own Mars sample return mission is currently being completely redesigned with international and private sector support, because the original plan ballooned to an estimated $11 billion cost. One thing we can say for sure is that right now, despite the budget and leadership challenges, NASA is still doing some pretty amazing exploration work on the planet Mars. And what they've just discovered with the Curiosity rover has some potential to really blow people's minds. If you're not keeping track, Curiosity is the older of the two current Mars explorers. It was launched in 2011 and landed in Jezero Crater in August 2012. It's a nuclear-powered six-wheel robot, about as big as a mid-sized passenger car, roughly the size of a Mini Cooper. For over a decade now, Curiosity has been slowly climbing Mount Sharp, a 5-kilometer-tall mountain of layered sedimentary rock in the center of Jezero Crater. Each layer represents a different era in Martian history, like reading the pages of a book that goes back billions of years. And recently, while analyzing a rock sample from a formation called Cumberland, Curiosity's instruments detected something remarkable: the largest organic molecules ever found on Mars. We're talking about long-chain hydrocarbons, complex carbon-based molecules that, on Earth, are associated with life. Let me break down what was found and why it matters. The molecules detected are called decane and dodecane. Decane has 10 carbon atoms linked together in a chain. Dodecane has 12. They're both hydrocarbons, molecules made entirely of carbon and hydrogen atoms. Now, hydrocarbons by themselves don't necessarily mean life. We find them in petroleum, natural gas, and even on comets. They can form through purely chemical processes without any biology involved. But here's what makes this discovery so intriguing. These particular long-chain hydrocarbons are chemically similar to the fatty acids found in biological cell membranes. Every living cell on Earth is surrounded by a membrane made of lipids, fatty molecules that create a barrier between the inside of the cell and the outside environment. These lipid molecules have long hydrocarbon chains as their structural backbone. The molecules Curiosity found could be degraded remnants of ancient biological lipids, the broken-down pieces of cell membranes from microorganisms that lived on Mars billions of years ago. The rock where these molecules were found is 3.7 billion years old. That dates back to a time when Mars was wetter, warmer, and potentially habitable. Jezero Crater used to be a lake, and the sediments that formed Mount Sharp were laid down in that ancient lake bed. If there was life in that lake, simple, single-celled organisms like bacteria, their remains could have been preserved in those sediments. And over billions of years, the organic compounds from their cells would break down into simpler fragments. Fragments exactly like decane and dodecane. This isn't proof of life. We need more evidence. But it's one of the most tantalizing clues we've ever found. Meanwhile, the European Space Agency is preparing for their own attempt to find life on Mars. But they're doing it under the shadow of a troubling history. Europe has tried to land on Mars twice before. Both attempts ended in failure. In 2003, the Beagle 2 lander separated from the Mars Express orbiter and descended toward the surface. It was supposed to land, deploy its solar panels, and begin searching for signs of past or present life. But after it entered the Martian atmosphere, all contact was lost. For over a decade, no one knew what happened. In 2015, NASA's Mars Reconnaissance Orbiter finally spotted Beagle 2 on the surface, intact, but with its solar panels only partially deployed, blocking the antenna. It had successfully landed, but a mechanical failure meant it could never communicate. It sat there on the surface, so close to success, completely silent. In 2016, ESA tried again with the Schiaparelli lander as part of the ExoMars program. This time, a software error caused the descent engines to shut off too early. The lander fell 3.7 kilometers and hit the surface at over 300 kilometers per hour, creating a crater and scattering debris across the landing site. 2 attempts, 2 failures, both agonizingly close. Now ESA is preparing for a 3rd attempt with the Rosalind Franklin rover, a $1.3 billion mission that represents Europe's best chance to finally succeed on Mars. The pressure is enormous. The ExoMars mission was originally scheduled to launch in 2022 using Russian rockets and Russian landing technology. But after Russia's invasion of Ukraine, all cooperation was severed. The mission was stranded, a billion-dollar rover with no way to get to Mars. ESA scrambled to find alternatives, and the solution they've come up with is genuinely impressive in its international scope. Airbus, the European aerospace company, has taken over the lander development, redesigning it to replace all the Russian components. NASA is providing the rocket, a SpaceX Falcon Heavy, to launch the mission. And NASA is also supplying critical heating units to keep the rover warm during the frigid Martian nights, since the Russian radioactive heater units are no longer available. The new launch date is set for December 2028, assuming everything goes according to plan. This is international space cooperation at its best. When geopolitics destroys one partnership, others step in to keep the science moving forward. If Rosalind Franklin succeeds, it will drill up to 2 meters below the Martian surface, deeper than any previous Mars mission, searching for organic molecules and biosignatures protected from the harsh radiation on the surface. Between NASA's Curiosity and Perseverance, China's Future Sample Return, and Europe's Rosalind Franklin, the next decade could finally answer the question, did life ever exist on Mars? But as we're planning these ambitious missions, it's worth remembering just how difficult spaceflight really is. And Europe got a dramatic reminder of that recently with the launch of the Spectrum rocket. Izar Aerospace, a German startup, has been working for years to develop Spectrum, a medium-lift rocket designed to compete with SpaceX's Falcon 9 and other commercial launchers. It's supposed to be capable of putting 1,000 kilograms into low Earth orbit at a fraction of traditional costs. The first orbital test flight launched from Andøya Space Center in Norway, the first attempt to reach orbit from mainland European soil. The engines ignited. The rocket lifted off. For a few seconds, everything looked perfect. And then it started to wobble. The wobble got worse. The rocket tilted off course. And within seconds, the flight termination system kicked in, shutting down the engines before the rocket could go completely out of control. The Spectrum fell back to Earth and crashed in a fiery explosion just seconds after liftoff, destroying itself but leaving the launch pad intact. It was a dramatic, explosive failure broadcast live. Millions of euros and years of work reduced to scattered wreckage in moments. But here's the thing. Izar Aerospace called it a partial success. The flight termination system worked exactly as designed, shutting down the engines instead of detonating the rocket. The launch pad survived intact. And most importantly, they collected enormous amounts of data from those few seconds of flight. Data that will tell them exactly what went wrong and how to fix it for the next attempt. This is the reality of spaceflight. Failure is part of the process. SpaceX blew up countless Falcon 9 prototypes before achieving reliable launches. Rocket Lab's first launch failed. Virgin Orbit's first launch failed. Even NASA's early rockets had catastrophic failure rates. The key is learning from failure and trying again. And that's exactly what's happening across the global space industry right now. China is pushing forward with an aggressive roadmap to explore the entire solar system. NASA is uncovering tantalizing clues about ancient life on Mars. Europe is persisting despite setbacks, redesigning missions and trying again. The race to explore the solar system is accelerating. Despite budget cuts, despite leadership uncertainty, despite rocket failures, despite all the challenges, the drive to explore continues. NASA's discovery of complex organic molecules on Mars could change everything we thought we knew about the history of life in the solar system. If those molecules really are biological remnants, it means life arose independently on at least 2 planets in our solar system. And if it happened twice here, it's probably happened countless times across the universe. That would fundamentally change our understanding of our place in the cosmos. The next decade will be critical. China's missions to Mars, Venus, and beyond. NASA's continued exploration with Curiosity and Perseverance. ESA's Rosalind Franklin rover drilling deep below the surface. And eventually, human missions returning samples for detailed analysis in Earth laboratories. The answer to one of humanity's oldest questions, are we alone, might finally be within reach. Stay tuned. The most exciting era of solar system exploration is just beginning.